Quousque tandem abutere Catalina potentia nostra? Are you looking for some translation, like this opening from Cicero's famous quotation in ancient Latin? Well, we can't help you with that today. Because in electronics, translation is just another word for level shifting, which is all about volts and currents and not about nouns and verbs. In this episode, we'll look at the reasons for level shifting and the many solutions available. Why do we need level shifting or voltage translation in the first place? It all has to do with the nature of semiconductor processing. Sure, we can say that a logic high is 5 volts and that a logic low is 0 volts. But is that completely true? In reality, in 5-volt TTL, an input high signal is actually defined as a voltage above 2 volts and a low as any voltage below 0.8 volts. But then along came CMOS logic, and for a variety of physics reasons, these devices interpreted high inputs as anything above 3.5 volts and low inputs as anything below 1.5 volts. See the issue here already? As each new process and family came along, the high and the low signals changed a bit, until finally you ended up with something like this. Now, as long as you stay with one family, there's no real problem. A 5-volt TTL output could talk to a 5-volt TTL input with no confusion. But as new processes became available, not every single function was converted to the new process. So sometimes you ended up having to buy one logic gate in 5-volt CMOS and perhaps another one in 3-volt CMOS, and you had to make them talk together. And you get something like this. When a 3-volt CMOS device outputs a high signal, this really means that it applies a 2.5-volt signal on its output pin. But if you hook this output to the input of a 5-volt CMOS device, this device only recognizes a high signal as above 3.5 volts and a low is below 1.5 volts. So what in the world does it do with a 2.5-volt signal? Is it a high? Is it a low? And what might happen to your circuit if the device just doesn't know? So both devices are actually speaking in binary, but in totally different voltage languages. What we need then is a way to translate or level shift between two different voltage systems or domains. Now sometimes we only need to shift from a lower voltage domain to a higher one. Sometimes only from the higher domain to the lower one. But sometimes we need to convert both directions, depending on which way the signal happens to be going. Let's look at each one of those in turn. For high to low level shifting, you can make the outputs of the sending side weaker simply by adding a current limiting resistor so that the lower voltage receiving device will see the correct level at its inputs. Or you can pick a device on the receiving side that can tolerate and understand a higher than normal signal in the first place. This is known as overvoltage tolerant inputs, and there are parts in virtually every logic family that can support this. You can easily identify these by looking at the recommended operating conditions and look if Vn can go higher than the supply voltage of VCC. For low to high level shifting, you can make the inputs of your high voltage receiving device simply more sensitive so that they can accept an input that seems extra low. Look for the feature called low threshold inputs in the datasheet, like this one, the 74 AUP1T57, for example. Or you could just ask the sending device to boost its output signal to the right level in the first place. This is called an open drain configuration, where the output of the device is pulled up to VCC through the use of an external resistor. An example of an open drain output would be the 74 AHC1G09. If you need to have bidirectional communication between the devices, both low to high and high to low translations, the best way might be to use one of the newer dual supply translators. These devices have 2 power supply pins. So you connect the low voltage power supply to one side with all its corresponding low voltage signals. Then you connect the high voltage supply and all its signals to the other side. And all the translation is done inside the device itself. Some devices even have an automatic direction control, so that when they change direction of the translation, even without having to tell it through a direction pin. This means that you can reduce the pin numbers, it saves logic and a package cost. An example of this device would be the 74AVC2T45 or the NTS0104. So, whatever your translating needs, from voltage domains of 0.8 to 5.5, and the number of channels from 1 to 32, from single direction to auto direction, there's a solution for it. So don't be afraid to do a bit of translation and learn a new language. As long as it's all in logic, you'll find that there'll always be a solution.